Hey everybody, it's Mr. Carr again. Today we're going to be talking about 9.4 day one. Technically, actually, day one and day two together as one lesson because this first part is actually super easy. So we're looking at the intersection of tangent segments outside a circle. Okay, so the intersection of tangent segments outside a circle. As a reminder, tangent lines are ones that cross a circle at exactly one point outside the circle. Okay, so when tangent segments form a common all right, a common eternal point, common external point are congruent. Okay, so this is what my diagram looks like. Point R and point S are points of tangency for two separate line segments. They come together at point Q. So when two tangent lines cross like this on the outside, the external, not eternal point, these two segments are congruent. So therefore, 3x plus 5 is equal to 32. And now we just solve this out. So we got to subtract 5 to both sides. 3x is equal to 27. Divide both sides by 3, and I get x equals 9. And that's all I need to find there. Okay, so that's what we're looking at in this scenario, and that's it. Two tangents come together, you set them equal to each other. So you can try that on your own with a little bit of quadratics with the x squared, but I'm going to go on to properties of secants. So this is a new term as well. Let's define a secant, okay? So secants are lines, let me see here, I got space right here. Okay, a secant. Okay, I'm just going to say it's a line segment that intersects a circle at 2 points, but extends outside the circle. So if you remember from the previous, well, not the last lesson, the lesson before, no, never mind, last lesson. Chords also intersect a circle at 2 points, but a secant is going to also exist outside the circle like these lines. PR and TR are secants because they cross twice, so 1, 2, and 1, 2. So they cross twice, but they also exist outside the circle. If two secants share the same endpoint outside a circle, then the products of the lengths of each secant segment and its external segments equals the product of the lengths of the other secant segment and external segment. That was loud. Okay. Whew. I'm sorry. This one's really confusing. And I'm not a huge fan of the wording of that one too, because it's also kind of messy. Here's what it's like. I think an easier way to do it. Basically, you're going to take the outer piece times the whole segment. And that's going to equal to the outer piece times the whole segment. That's the easiest way to simplify this. Okay? So here's my outer pieces here and here, the 5 and the 6. The whole thing is 10. This whole thing is x plus 5. So that's what we're going to say here. So I've got 6 times, so we got outer times the whole thing, 10, is equal to 5 times the whole thing, x plus 5. Okay? Every time we see two secants, that's what's going to happen. Outer times the entire whole segment. Okay? So that's going to be 6 times 10 is 60. I'm going to distribute the 5, so that's 5x plus 25. Subtract the 25 over, so that I get 35 is equal to 5x. Divide by 5, and I get x equals 7. Now the question says find the value of RT, which is this one right here. The value of RT, remember, is x plus 5. So then I can say that RT is equal to 7 plus 5, which is 12. Okay? So again, main idea here for secants that are intersecting like this. It's outer times the whole thing. Now, we did kind of skip one idea, and that's this one right here. This is actually the intersection, and it calls it secants, but it's actually a secant and a tangent that are intersecting here. So we're going to kind of still do the same thing. This side right here is a little bit weird though. If I follow, like, let me set it up as this way again. So outer times whole equals outer times whole. So I'll do this one first because the whole thing is 16, 9 plus 7. So the outer piece is 9 times 16. Here, if I look at the outer piece, well, x is completely outside, but x is also the whole segment. So that's kind of my setup there. I'm going to take that x and multiply by itself. That's all. I can still apply the idea of outer times whole here. It's okay. So I got 9 times 16. So it's going to give me 144 is equal to x squared. Okay, now I can square root this. X squared equals 144, and I get 12 for x. Okay, that's it for secants. Okay, these are our segments that we're analyzing that intersect outside the circle. Either two tangents intersect so that they are congruent to each other, or we get a secant intersecting with a secant, which is this outer times whole equals outer times whole, or we get a secant and a tangent, which is still outer times whole, outer times whole. All right, that's it for today. Talk to you again on the next lesson. All right, take care, everybody.